Hello friends, this is Priyanka. Today we are going to solve a problem on economic load sharing between base load plant and peak load plant. In this video, base load plant always works at full load condition. Energy units generated during off-peak period are converted into electrical energy with 60% efficiency. And for this given condition, we have to find out what is the capacity of the peak load plant. First, I will read what is the given question. The maximum and minimum demands of an industry are 50 megawatt and 10 megawatt respectively, and these vary linearly. The hydropower plant can take the load of 60 megawatt hour per day of the factory at the time of minimum regulated flow, and the remaining is supplied by thermal plant. It is proposed to pump the water from terrace of the existing plant to reservoir during off-peak period of thermal plant and allowing to the thermal plant to run always at full load condition to economize the supply of power. If the overall efficiency of the conversion of steam of peak power to hydel potential power and then hydel power to electric power is 60%. Calculate the capacity of hydel plants considering the pumping of water during off-peak period of the steam plant. So this was the given question. Let us first understand the given data, and with the help of data we will draw the load duration curve. Maximum load and minimum load is given 50 megawatt and 10 megawatt, and during this the load curve varies linearly. Hydel power plant load is given 60 megawatt hour per day. Now if we observe the units, it is megawatt hour, that is the number of energy units generated for a period of 24 hours is given. Thermal power plant will act as a base load plant, and hydel plant plus pump storage plant will act as a peak load plant. Thermal plant always works at full load. So energy units generated during off-peak period of the thermal plant are converted into electrical energy, and this conversion is taking place with efficiency, and this efficiency is 60% efficiency, and it is getting converted by the pump storage plant. Now with the help of this data we will draw the load duration curve. Now here demand limits or maximum and minimum load is mentioned in megawatt. So for this vertical line we will plot here the load in megawatt. So we will start from 0. So here is 0, then 10, and here is the 50. That is, this is the minimum load and this is the maximum load. And during this maximum to minimum load varies linearly. So we have to draw a straight line. Then time period that we have to take, that is time in hours. So if we observe hydel power plant load is given for one day, that is 60 megawatt hour per day. So in one day there is the time period 24 hours. So from 0 to 24 we have to plot here the time in hours. Now we will draw the load duration curve. So for that I will take, this is the minimum load. So this minimum load will also work for this for 24 hours. So I will draw one horizontal line from this minimum load, and then I will draw here one vertical line also. Now what is given that from this maximum load to the minimum load curve varies linearly. So we have to draw here one straight line or one. So this is the load duration curve. Now our question is that for the economic sharing, that is between base load plant and peak load plant. So how to decide this economic sharing? So for the economic sharing between base load plant and peak load plant, we have to divide this total area under the load duration curve into two parts. So I will divide this total area by a horizontal line. So I will draw this line with the help of red marker. Now we will consider here this length of this horizontal line will be x. That is, what is the unit of x? So this unit of x will be in number of hours, because this line is parallel to this time in hours. So here is the x. Now we will consider the load, that is the load above this horizontal line x will be, we will consider one particular notation, that is y. Now if we observe this diagram, we can say that the load is getting divided into two parts. So by this horizontal line, so below this horizontal line the load taken by the base load plant, and above this horizontal line the load taken by the peak load plant. So this y is nothing but the load taken by the peak load plant, and after that from this 0 the remaining load is taken by the base load plant. So I will draw here one vertical line. So what is the load taken by the base load plant? So from this diagram we have to decide the value of this vertical line. So this total load is 50. So 50 minus y, that is nothing but the load taken by the base load plant. So I will write here as a 50 minus y, and here I will write y. Now given condition is that base load plant always works at the full load condition. So always works means what? It works for a 24 hours. So here this is the line for the economic load sharing. So we will extend this line up to 24 hours. So during this period the energy units generated are due to off-peak period. So I will highlight this area. So this area is nothing but the energy units generated by the base load plant during off-peak period, because during this period there is no any energy units are required. But because the base load plant always works at the full load condition, here after this x number of hours also the plant is working. So what is the number of hours? So what is the value for this horizontal line? So again we will decide this value from the diagram. So I will mention here. The value for this horizontal line is nothing but this 24 minus x. And what is the value for this vertical line? So again from the diagram we will decide this. Now if we observe from this 10 to 50, this whole distance is 40. And this 40 minus y. So 40 minus y is this remaining distance. So I will write here as a 40 minus y. Now again it is given that the energy units getting generated during this off-peak period are converted into electrical energy with the help of pump storage plant. So this pump storage plant and hydel plant works as a peak load plant. So these energy units generated are getting converted into electrical energy for this peak load plant. So we have to take some area or we have to show some area, and that area is equal to this energy units generated, but here condition is given that 60% efficiency. So I will show this area in the peak load plant here. So the load above this horizontal line is nothing but load for the peak load plant. So energy units is nothing but the energy units generated, that is nothing but the area for this whole triangle. But only we have to show from this triangle, we have to show some area that is taking place is because of this energy unit. So I will show this area. So only small part is getting covered because of this energy units generated. So if we observe, the energy units generated during this off-peak period is getting converted into electrical energy, and here this space is getting mentioned with 60% efficiency. Now I will give the notations for this diagram. So I will give here A, then this point will be B, this point will be C, here is D, E, F, then here will be G, here will be H, here will be I, and here will be Z. If we observe this diagram, then here the area of triangle AGH is the energy units generated by the hydel power plant. Then area of the shape BCHG is the electrical energy that is getting converted during the off-peak period of the base load plant with 60% efficiency. That is, off-peak period for the base load plant is nothing but the area for this triangle CDE. So during off-peak periods, how many energy units are getting generated? That is equal to area of triangle CDE. Then what is the energy units generated by the base load plant? So here area, that is BCEJI to B. So this is the area, that is the energy units generated by the base load plant. Now as per the given conditions, electrical energy is getting converted from the energy units generated during off-peak period with 60% efficiency. So how we can write this statement? So electrical energy is getting generated is shown with this area, that is area of the shape BCHG. So this area, that is equal to 60% efficiency multiplied by area of triangle CDE. So we will write this statement, that is area of BCHG is equal to 60 by 100 area of triangle CDE. Now how we can rewrite this? So if we observe this diagram, here the area of triangle ABC minus area of triangle AGH. So if we take this subtraction, then we will get this remaining area. So we will write this, that is area of triangle ABC minus area of triangle AGH is equal to 60 by 100, that is 0.6 area of triangle CDE. Now area of triangle ABC. So if we observe here area of triangle ABC, so here BC is base, height is AB. So how we can find out area? That is half multiplied by base multiplied by height, that is half multiplied by x into 1 minus area of triangle AGH. So area of triangle AGH, that is nothing but the energy units generated by the hydel power plant. So this hydel power plant, it is given 60 megawatt hour, but energy units generated we will always take in kilowatt hour. So we will convert it into kilowatt hour, that is 60 into 10 raised to 3 kilowatt hour, which is equal to 0.6 into area of triangle CDE. So again here 40 is taken in megawatt. So we will convert it into kilowatt. So how we can write this area of triangle, that is half multiplied by base multiplied by height. So we will take this as a base and this is the height. So multiplied by half multiplied by base, that is 24 minus x multiplied by height. So height, instead of 40 megawatt we will take here as a 40,000 kilowatt minus y. Now we will simplify this. We will multiply these two brackets. So we will write here half xy minus 16 to 10 raised to 3 is equal to, now 0.6 into half, that is 0.3 in the bracket. Now in the bracket we will multiply. So 24 multiplied by 40,000, that is 916 to 10 raised to 3 minus 24 into y, that is minus 24y. Now this minus x into 40,000, that is minus 14 to 10 raised to 3x, and this minus x minus y, that is plus xy, and this bracket is getting completed. Now we will move for the again one equation. So how we will get this equation? So if we observe the diagram, there are two triangles, that is this triangle ABC and this triangle AFE. So if we observe these two triangles, then if we take the ratio of sides, then we will get the equation in the form of x and y. So we will take the ratio. So if I take the ratio for this height, then we will get, for this triangle ABC, it is y divided by, what is this height? That is, it is 40. So we will write y divided by 40,000. So if we observe from this 10 to 50, what is this total distance? That is 40 megawatt. But here we will convert this into kilowatt and we will take the value in kilowatt, that is 40,000, which is equal to, now we will take the ratio of the base. So base is this BC divided by FE. So this BC is x hours and this FE is for 24 hours. So x divided by 24. So we will calculate the value. Therefore y is equal to 40,000 x by 24. Now we will put this value. So I will give here, this is the equation number 1 and this is the equation number 2. So we will put this value of y in the equation number 1. So instead of y, we have to take 40,000 x by 24. So I will again rewrite this, half multiplied by x into 40,000 x by 24 minus 16 to 10 raised to 3 is equal to, now 0.3. Now here in the, we will put the same bracket, that is 916 to 10 raised to 3 minus 24 into 40,000 x by 24, and here minus 40 into 10 raised to 3 x we will write as it is, and here instead of y we will write 40,000 x by 24. So x multiplied by x, that is 40,000 x square by 24. Now again if we observe, we will multiply with this 0.3 inside the bracket. So again we will write here, so if we observe this left hand side, so we can simplify this, that is half multiplied by 40,000 multiplied by 24, that is 0.83 into 10 raised to 3 x square minus 16 to 10 raised to 3, and on the right hand side if we multiply by each term with 0.3, then 288 into 10 raised to 3 minus 12 into 10 raised to 3x minus 12 into 10 raised to 3x plus 0.5 into 10 raised to 3x square. Now we will separate the each term in the form of x square, then in the form of x and the constant term. So we will take this plus 0.5 into 10 raised to 3x square to the left hand side, then it will become 330x square, because 10 raised to 3 as a common, then 0.83 minus 0.5 that we have to take, and then we will take here as a 0. That is 0.33 is the answer, then 0.33 multiplied by 10 raised to 3, that is 330x square, minus, then here minus 12 into 10 raised to 3x minus 12 into 10 raised to 3x. So this minus minus we have to add, minus 24 into 10 raised to 3x. So here this minus, so here minus 24 into 10 raised to 3x, but it is on the right hand side. So if we take this in the left hand side, it will become 24 into 10 raised to 3x. and here minus 60 into 10 raised to 3. So if I take this term 288 into 10 raised to 3 to the left hand side, then it will become minus sign. So minus 60 minus 288, that is minus 348 into 10 raised to 3 is equal to 0. Now again we will divide this whole equation with 330. Then it will become x square plus 72x minus 1054 is equal to 0. So this is the second order equation and we have to find out the value of x. So how to find out? The roots for this equation? So we have formula, that is minus b plus minus square root of b square minus 4ac divided by 2a. So this is the value of x. Now what is this a, b, c? A is nothing but the coefficient of x square. So a is equal to 1, b is equal to 72 and c is equal to minus 1054. So now I will put the value in this equation. Therefore x is equal to minus b, that is minus 72, plus minus under root of b square, that is 72 square minus 4 multiplied by a is 1 multiplied by c, that is c is minus 1054. So minus 1054 divided by 2a. So 2a, that is 2 into 1. So simply I will write 1. So we have to solve this bracket first. So here minus and this minus sign will become plus. That is square root of 72 square plus 4 multiplied by 1054. And then we will solve this. So when we solve this, we will get x is equal to minus 72 plus minus 96 by 2. Now here x is the number of hours, so we have to take positive number. So 96 minus 72 by 2, that is x is equal to 12 hours. Now if we put the value of x in to calculate the value of y, then we will get y is equal to 40,000 multiplied by 12 by 24. That is 20 into 10 raised to 3 kilowatt. Because here 40 is in kilowatt, so here answer will also in kilowatt and we will get here the answer is 20 megawatt. Now if we observe this diagram, the value of y, that is nothing but the capacity of peak power plant, that is equal to y and that is equal to 20 megawatt, and this is the answer.